Hey guys, welcome to the Rational Optimization Podcast. My guest today is Guido Morera. He's a student of cognitive science and artificial intelligence here in Tilburg University. And I want to be honest, this podcast, my goal is to provide as much value as I possibly can to you. And this today was more of a free conversation than like a structured try to discover the meaning in life, discover what is the most rational thing to do. So if you want to learn more about concrete philosophy, then maybe go to another episode. But if you're in for a actually interesting conversation about studying and artificial intelligence, really different ideas about artificial intelligence, then you're at the right place. Enjoy. Hey Guido, tell me, you study cognitive science and artificial intelligence. What made you do this? What is the reason behind this?
Oof. Do you wanna like the real story or the feel good story?
Tell the real story.
Okay. I was living in Slovakia. I'm from Italy, by the way.
Yeah, okay.
People wouldn't know. I was living in Slovakia for 2 years at the time because I was working there. And
How old are you now?
25.
What have you been working in Slovakia?
Yeah. That's the thing. I was not qualified to do any high level work. I didn't have any, it's not even, I didn't have the titles, like this paperwork that says, oh, I can do this. No, I didn't even have the skills because I had never worked on, let's say, programming on my own or learning art or music, whatever. I had, not only I didn't study formally, I didn't even study interior, just watching YouTube the whole day when I wasn't working and learning random assortment of things, but they're never particularly useful as an ensemble. And I was a job hopper. Well, like not a professional job hopper, it's not a title, but I was working for Amazon as a data entry, which is really, really boring. Like imagine a task that you have to do as a target 1,300 times per day. Like during the job interview, I was there, like they told me this and I was like, wait, that's about 5 seconds per task. And she was like, whoa, you're good at maths. Like, yeah, that's not going to help me in this job because it's going to be boring anyways. So I did that for slightly longer than a year. Well, it wasn't the worst.
8 hours every day.
8 hours every day, 5 days a week. 1,300 items per day. It was not the worst, but it was not good at all. Like it was mind numbing. Like the thing is, it was during COVID, so there was not much to do anyways, and I was living with my girlfriend. So I was working from home all the time. It wasn't that bad. Like she was studying, I was working. It was a good time. But the job was really mind-numbing to the point where I couldn't take it anymore and I wanted to change again after like a year. My previous job, I also only lasted a year. The job before that, like 3 months. So I was not, I was like, oh, I'm going to skip studying and go have a career. And I was not going to have a career because I didn't like anything. That's when my girlfriend pointed out, like one evening I was complaining about this type of stuff. And my girlfriend pointed out, Guido, you spend like 4 hours a day watching YouTube videos about artificial intelligence. And I was like, yeah, so what? You can study that, right? Like, duh, of course you can, but like, not me. I was a shit student. I can't study. I graduated high school with, an average grade, like 80% on the final exam. But in my final report before the exam, right, I had 6 out of 10, which is the minimum in every subject, except one when I had a 7 in maths. You get a grade for your behavior in Italy. I had 6 in that as well. Not because I was like people who have 6 usually smoke in class or they're just general dickheads and will yell at professors. I was super like quiet kid, good kid. I was just skipping class as much as legally allowed, to where you're allowed to have 250 hours of absence in Italy, and I had 250 hours. Otherwise, if I had one more hour, I would have had to repeat the year. That's how bad of a student I was, And I tried university when I graduated high school. chemical engineering for one semester. I had to take calculus, I had to take chemistry 1, and I had to take linear algebra. And of the 3 subjects, I only passed linear algebra with like an 8 out of 10, and the other 2 I bombed. The 2, important ones, like algebra was considered easy. It's calculus and chemistry, which are hard ones in chemical engineering, right? So I was not a good student all around. And my girlfriend suggests, oh, why don't you go and pursue artificial intelligence? It took me a little while to convince myself that it could actually be a thing. Because I had also a bad experience in high school where my programming teacher was so horrible that I thought I will never want to be a programmer in life. And now it's all I want to do. Like, I got an assignment. We were programming in C++, this subject. We had to program a maze solver. The deadline is in 3 weeks from now, and I already finished it a week ago. Because one night I started working on it at 8 p.m. and I didn't go to sleep until I was done at 4 a.m. in the morning because I was enjoying it so much.
Yeah, I love programming. You can get so into it. Like, I didn't do that much programming, but whenever I do it, I'm like, it's like math. It's beautiful, and you solve a problem. You have immediate feedback. You're like, I really have to concentrate. Yeah,
when it goes well, it's so fun. I have a project that's been holding me back lately a little bit, but I'm gonna be done with that soon. And I can go back to more pleasant endeavors. But when it goes well, it's so fucking fun. Like, I play puzzle games, occasionally. Like, I am a mild gamer. I used to be a full-on nerd when I was in high school. Now I just play 1 hour a week or 2 when I'm not busy with other stuff. And puzzle games are something I do. Or even simple things like Sudoku and stuff like that. Programming feels like a game. Feels like a puzzle game. It just, you have a very, very large box of puzzle pieces and you don't know what the final image is supposed to look like. And you just try and combine them together until you get what you want the image to look like.
Yeah. True.
That's what it feels like to me, at least.
Yeah. I don't like puzzling that much because like it feels so pointless. Like, it feels so incredibly. It's like, here, I bought this puzzle. I bought like work for no reason. It's like,
I get that. I don't mean puzzles in that sense because I haven't done one of those since I was like 8. I mean, like, for example, strategy games where you have to manage. I was playing for a while Civilization, where you have to manage a small empire throughout 2,000 years of history.
So computer
games, absolutely. Or even just like escape rooms, but digital. That would be like a puzzle game. There's a lot of things, or just mazes, things like this. Things that take logic and thinking to solve. It's not just a first-person shooter game. Instead, doesn't require a lot of I might offend someone like this, but doesn't require a lot of strictly logical thinking. It requires much more reflexes and accuracy in your movement with the thumbstick and whatnot, or with the mouse if you're an actual gamer. Instead, I like to play games that engage the mind, right? And programming feels like a game when it's going right, when it's within your skill set.
Yeah. When you like write that this a little bit harder. Exactly.
I kind of came up already earlier in the conversation, the flow state. When you're in the flow, and that's, I think, an actual psychological term, being in the flow, right?
Yes.
You're challenged, but not excessively, so it doesn't become frustrating. And you manage to stay focused for way longer than normal. And it's satisfying work that you do during that time, that when you're done, you're tired but not stressed and exhausted. You're just tired and satisfied.
And proud. It's like, I it depends on what you do, but I think if you also want like the output, and of course, if you work really hard on something you want to work on, of course you're proud in the end. And I think it's like the numbers. I don't know how they came up with this number, but it's either 4 or 7% that it has to be harder than your skill set, so it's like slightly exceeding what you can do,
Okay.
but only like not too much.
Only like a
And it's
small
like,
percentage,
yeah,
like
exactly,
a 20th of your work should
Yeah,
be.
exactly.
I
So
think that feels low. Are you sure about that?
yeah, it's 4-7%. I'm pretty sure about this.
That might explain why I feel so challenged, because I take on tasks that are way above 4-7% above my competence level.
But the thing is, if you like, it's not really, because you have like, if you count like Google in and everything, if you're allowed to use ChatGPT and stuff, and then you can go use this, and like that way your competence is like higher maybe.
Yeah,
but
I'm telling you, even accounting for that, I have taken on projects that were way more than I could like shoot off more than I could bite, or whatever, beat off more than I could chew. How's the term? Doesn't matter. I'm not an English native speaker. But like, even with ChatGPT, and let's be clear, I use ChatGPT Plus because like I use that 3 hours a day every day or something. Like I'm on ChatGPT a lot.
Is it a lot better? A lot better. You have like the premium version.
Yeah. You don't?
No.
I'm so surprised. Do you use ChatGPT a lot?
Sometimes, yeah.
Okay, if it's like more than twice a week, you should consider it.
Yeah, is this like, I think the free one is 3.5.
Yeah. And GPT-4 is the...
I heard that it is much better.
But it is much better. It's hard to explain why, because like you could get the same identical output from both versions, but getting to that output with 3.5 will be way more frustrating. It's like 3.5, you're talking to a kid, and like you have to come up with tricks and fun things to make it do what you want to. And GPT-4, you're talking with a cooperative adult who, you know, might not be the smartest in the world, but will do what you ask him to. It's like, it's willing to do what you want him to. So I tend to genderize it because in my native language, we don't have neutral. Anyways, with GPT-4, you tell him do this and it does that to the best of its abilities. 3.5, you're like, what's 3 times 7? And it's going to be, I don't know, sounds about 15.
Okay.
GPT-4 would be like, let me give it a shot, and tries to do some calculations. Sometimes they're wrong, but at least it does what you're asking it to. So I think it's much better in that sense.
Okay. How much do you pay for it?
It's a bit expensive. It's like $20 per month, but with the conversion to euro and some added taxes, like 25 euro.
Wait, conversion to euro should be cheaper.
I know, but I think they add the taxes in the US and the taxes here. So it's, maybe not the conversion itself, but you have VAT twice. So it turns out to be fairly expensive for a student. For any working professional, it will be something I would strongly recommend if you can afford $20 a month, because it does help. It makes me like 5 times more productive, straight up.
It's
Well, okay, 3.5. The free version will make me twice more productive, probably, than baseline.
Do you only use it like in the chat, or can you use like this version also like in the, like, for example, read like files of your computer and stuff? Or
I do not use that.
But it would be possible.
It will be possible. Like you have to upload the files and let it do its own thing on it. I've actually never bothered trying, because when I do, for example, statistical, because it's usually for data analysis. When I do data analysis on something, I mostly know what I want to analyze anyways. And I'll just ask it to write an R script or a Python. I often do data analysis in Python, which is not the thing I would recommend for everyone. But I just ask it to write a script for me in Python, and I just run it myself. I don't need it to run it on GPT-4. But I think it's possible. I've never tried it. I never bothered. I haven't been doing that much data analysis lately anyways.
I was trying, like, for the podcast, like I give ChatGPT the transcript of the podcast and tell it to give me like a transcript with like timestamps as well, and tell me to give like the most interesting moments so I can make short videos out of it, you know? But
wait, how do you get the timestamps?
You can just make a transcript, and this transcript is like at 25 minutes and
Okay.
15 seconds
You
this
use some, like,
sentence, and it's like, yeah, some
You don't do them manually. That's what I was
no,
wondering.
no.
You're like, yo, that's fucked up.
Nah.
With the amount of podcasts you've
Bro.
been recording as well.
No. It's just like some internet tool. You just put the podcast in, the audio, and they give you a transcript. And I feed this transcript to ChatGPT.
Yeah.
But the thing is, it's super confused if you give it like,
Because it's a
like
lot of info.
so much text. It's like
that will definitely.
And then it's like super confused and forgets the question you asked in the beginning. And is this the same with the 4 version?
It's way better. It
Yeah.
can handle actually big amounts of text.
Hmm.
Not that well. It does still forget things unless you remind it about them. So you're like, oh, remember the question I asked you earlier. And it's gonna remember that. Maybe after like 1,000 tokens, like after 2,000 tokens, which is 10 pages of text, which is a lot. It's gonna forget what you said at the start unless you remind it of it.
Yeah.
But it's still, I think a whole hour and a half podcast should probably all fit within this amount of
that's
token.
why I'm thinking, like, if you can make like the files and give it the files, this is maybe better, that you can like
might be better,
reference,
actually.
that you reference like, oh, this transcript, like, and you reference to a document.
Mm-hmm.
So but I don't know.
I think there's one that I know someone who uses it for studying. It's called pop.ai, I believe, which takes PDFs or text files, and it will answer questions about those files.
Yeah.
You might want to try something like that.
Yeah.
Like it reads the whole document, like, I don't know how it actually reads, but it reads the whole document and gives you back an answer to that, which should be fairly accurate as far as I know.
Yeah, there are multiple of those. I had one, Readwise. Readwise is really cool. You can put like books in there, or it's like you can put everything in there. You can put books in there, websites, whenever you read like something, a PDF, like a study or stuff, and then you have just shortcuts to save like essentially everything. Like when you're browsing, if you have a YouTube video, you can like save the YouTube video, and it gives you like the YouTube video with the transcript and everything. And you can also ask everything questions. So this is I was using this. And I also...
Does it work? Have you tried it with your transcripts from the podcast though?
Nah, I don't have it anymore. I just because it's like $10 a month or something, and I was like, I don't really need it. Like it's fine if I just take notes from YouTube videos. I don't have to have like...
You're more efficient than the AI model, aren't you?
Yeah, I don't really need it. But this is like an idea. I also found another thing. It's for scientific studies.
Mm-hmm.
It's like also with AI. It's like a database, and they use AI, and they have like a lot of all the scientific studies inside, and it's like a more efficient database where you can also ask like questions about the study, and it takes out like the most important parts. So like, it takes like the metadata, but it creates it itself, because like if you have studies, it would be really cool if you have like a super ordered, like if you have a scientific paper, it will
give it proper index terms and things like that.
Exactly, and like how many participants, what exactly was the intervention, for example, or what exactly was the outcome, and everything like nice and sorted, and what exactly was the topic. And you can search by topic, and it gives you like, or you can ask it a question, and it gives you studies that answer this question, and it also summarizes.
Wait, have you been using that, or you just found it and like
I
thought it was interesting?
I started using it, but it's like already half a year ago or something, and I because I used like the free trial or something, and they still send me emails, so I know like they're improving, because they're always like, okay, we added this feature, we added this feature.
Okay,
but I have to look into it, because this is like, I think this can be really good. Like
it's interesting though, because like a lot of the tools you find are really geared towards academic research, which is something I'm interested in doing, but I'm not really doing. Like I did write one paper, we're waiting to know if it's published. We'll know in a couple of weeks. But besides that, I'm not doing any other research at the moment, and I'm not planning on doing research besides my thesis next semester. And will even just the thesis justify a tool like that? Like, because it's not interesting if you just use it for a week. You have to use this over 3 years to have is like compounding interest. Like if you keep doing that,
and you really
keep
know
adding,
how to use it, and
you keep adding stuff to your database of information, right? And then is that not how it works? I thought it was like Obsidian but automated with AI.
No. This was the first one. Now the second one is a database of it's like
it is a full database already, like
all studies inside.
I thought you were making your own database using that.
No.
I see.
It already has like a lot of studies. It's just like
and is it paid?
Yeah. I can send you.
I might check it out.
Yeah. Because
there's a lot of ways to find interesting papers for what you're studying, but there's not a one size fits all solution, and this sounds like could be better than many other methods I've tried. So would be interesting.
It would be nice if I find the.
Speaking of thesis,
tell me what is your.
Whether can you decide my topic for me?
Of course, man. Tell me what is.
Yeah, man. I don't know. I have this is quite an interesting time to do the podcast with you because I haven't decided the topic yet, but also I have a self-imposed deadline to decide by next Monday what the topic of my thesis is going to be.
Okay. It's Tuesday, so I have 6 days left.
Yes. So I'm open to ideas. Like I've been offered by some professors to work on very, very interesting topics. The ones that caught my attention the most are trying to discover new species of birds using audio recordings, because you will have classifiers, right, that can tell you from an audio recording what bird you're listening to. But if there's a bird you've never classified before, most models will inaccurately classify it as something else. So the professor was like, why don't we make an AI that can understand if a recording is a new unidentified species? That would be very interesting, I think. There's also a thing where like, how useful would that be? How impactful would that be, rather? Because it depends how many people are going to use that as well. And, how many undiscovered species of birds are there that we do have recordings of? Well, we can't know, I guess. I don't know if someone tried to estimate it. But I think that would be very interesting to know in general. Other things is like related to games. We have a professor here on Tilburg University that works with, several actually, that works with serious games, which is, for example...
Serious games?
Serious, like, games for fun and games for useful things. I met one PhD student who was doing his research with the port of Rotterdam, I believe, and they are training operators using a game he's developing in their
port operators. Yeah.
With like people who are, I think, moving around their container box, shipping containers rather. People are moving around shipping containers. They need training, right? And so there's some research that's going on at the moment into seeing if playing some games will help you with that, will improve your skill. And there, I think, has a purposely designed game specifically for training on that, but also games that are apparently not related. For example, the one I was mentioning earlier, actually, Civilization, which is just a long-term strategy game. How does your skill in that game correlate to how well you can move around shipping containers? And apparently there's like a significant correlation between the two things, where like if you play the game, and it's not only it's also a causal relationship to where if you play the game longer, if you get more skillful at it.
For real, like with games like Civilization?
Yeah, straight up.
Like it's about civilization.
It's several games, and one of them, unless I remember poorly, which is always a possibility, right? One of them was specifically Civilization. Damn. Plus, there was some purpose-specific games being developed. But it was, not my research, and I don't think it's published yet. So I don't want to give any wrong information. But I thought, we have people working with serious games. That's what I mean by a serious game, like something that can be actually useful besides entertainment. And turns out that maybe entertainment games can be useful as well in other ways. Or working with robotics. We have a robotics lab and deep learning. We have so many fucking things at this university where I don't know what to work on. There's like 5-6 professors I want to work with.
Damn. Explain what is deep learning.
Deep learning.
Yeah.
Man, that's a difficult question. Okay. I'll do my best, and if someone from the, someone who's listening to this notices a mistake on my part, I'll be happy to be corrected. Is this gonna go on YouTube as well, or is it only on Spotify? Okay, definitely in the comment section then. Yeah. Call me out on my bullshit if anything is like that. But I'll give it a go. What is deep learning? Well, to answer that, I will start with saying, in general, what is meant by artificial intelligence. And I will say that is any artificial system, and typically we mean computers, that can learn from a finite amount of information how to extrapolate what they learned to other informations they haven't encountered before. So, for an example, you have played 100 games of chess. It doesn't mean you have played all the games of chess that can be. But an AI will learn from 100 games how to play 1,000 more with hopefully better results than their first game it's ever played. And that's not something that comes natural to a computer, because a computer is not natural. It has to be designed to do what you want it to do. It doesn't just happen to do the right thing. So that's AI in general. And machine learning is what has been used for a long time. Is like one of the first approaches to AI.
Wait, stop about AI again. Like, the difference is like if you...
AI is like the generic term. I would say.
Yeah, like, but with the chess example, like a basic computer program, how like with the basic programming would be, if you're in this position, then you do this move.
Yes.
And AI is different.
I will say so. In some sense of the word, you could consider that to be AI as well, but it's not intelligence. It's just that's more of a. It's not like a technical discussion. It's more of a philosophical discussion. But if you do that, you will never learn a new rule that has not been explicitly programmed to you. So you're not learning, you're just implementing an example, like a series of examples. You're like, oh, if I'm in this example, I'll do that. If I'm in this, but if there's an example that you've never seen before, you don't have a move available. Machine learning is a step further than that. So you will use more traditional methods of, for example, support vector machine is a good example that comes to mind, or actually random forest might be easier. So you will have a series of if then rules that the computer comes up with. Mm-hmm. Okay. So you don't have to explicitly say, if in this position do that, if in this position do that. You're just gonna say, come up with 1,000 rules, and the computer will come up with 1,000 rules that lead to the highest success rate that it can find just by randomly modifying these rules.
And those rules can be also more complicated than exactly this position. This can be if
I have 10 more points of equivalent score on the board, then I can play this branch of trees, which are gonna be more aggressive. Otherwise, play the less aggressive. So you have it splits off into many decisions. So it's not one decision. It's not a 1,000 list of if then. It's if and then. Like there's branched and nested decisions. So that's something that is considered machine learning. And for example, also linear regressions, I think, is something that will count as machine learning. So you have you try to approximate a function where from a series of inputs will produce you the output. So from the current state of the board, of the chessboard, you're going to try to come up with an output, which is going to be the current move. It's not as simple as that, actually. I don't think it will work with linear regression, but for the sake of maintaining the same example, let's say
we have machine learning, and linear regression is something else.
I think no, it's a type of machine learning as well. There's many types of machine learning. Deep learning.
It's also a type of machine learning.
Yes and no, to where it is a type of machine learning in the same sense as is it though? some basic deep learning is definitely considered machine learning as well. For example, multi-layer perceptrons is a model I can think of, which is just what you will think of as a stereotypical traditional neural network. So you have 10 neurons, which are just, they take the sum of the inputs multiplied by a value. So each input is multiplied by a random number, a number. And then you add it all together, and that's going to be the input of one neuron, and it's going to output 0 or 1, depending if it's above or below a threshold. Yeah. And then you do that for 10 neurons. Each of them will have different weights. They're called weights. And different...
The weight is how easy they are?
No, the weight is what do you multiply the input by? So it's very abstract. I understand your confusion. You have, let's say, just 3 neurons, okay? And the inputs are 1, 2, 3.
In each neuron?
Sorry, the input to the whole system. You have 3 inputs, 3 neurons, and then 1 output. Yeah. The inputs are 1, 2, and 3. The weights for the first neuron towards all of the inputs are going to be 0.5, 0.5, 0.5. So the first neuron goes 1 times 0.5, 2 times 0.5, 3 times 0.5. You sum those up, and you get, what's that, 3 as the output or something, as the sum of the inputs. Okay. Once you have that sum of the inputs, you check if it's above or below the bias. You know how 2-minute paper always talks about...
I already don't understand the first part.
Okay.
So wait, you have 3 neurons. And
first 3 inputs.
3 inputs.
3 inputs are connected to the first neuron, and they're connected to the second neuron as well, and then they're connected to the third neuron. Okay. As well.
And the inputs are 1, 2, and 3.
For example.
Okay, but how is 0.5 coming out?
That's a weight. Those are the weights. So each of these connections has a number.
Okay, the connections have weight and the neurons have thresholds.
Yes.
Okay, I think now I understand. Okay.
Man, once your podcast gets a higher budget, you're going to have to add animations to what I'm saying. Yeah. But yeah, so in short, you take the numbers, multiply them by some the inputs, you multiply them by some number.
Yeah, I think,
and sum them together.
I can try to explain because I think you tell me if it's wrong, because if I just learned it, I will be the best one that can explain.
I think that's better.
Because if you just learn it, it's okay. So you have like a neuron or an input, and it's connected to another one, and you can just imagine like there's a ball here, it's a connection with, or there's a neuron here, it's a connection, and there's another neuron next to it.
Sure.
And the connection is like if this one sends a signal, like then this connection is like the connection can have a different strength. Like the connection can, and the strength of it's like it's the weight, or how did you call it? It is
called a weight. Yes, the strength of the connection.
And this is by how much the signal of this first neuron is multiplied before it gets to the second one.
Yes, absolutely.
Okay.
So and how do you determine if a neuron is gonna output or not a signal?
This is in the neuron. This is
It's determined by whether the sum of the inputs overcomes the bias or not. The threshold.
The bias is the threshold. So,
yes.
For example, this neuron needs at least 5 to fire.
Yes, exactly. So from the input example I gave you earlier, it will not fire. But maybe the second input, the second neuron had higher weights, so it will fire. And so if you have multiple layers, that's why it's called a multi-layer perceptron, because you usually stack them. You have one layer, then one layer, and they're all interconnected. That is also usually called a dense network, or like a dense layer, usually when you have more advanced models, or fully connected neural network. These are all different names for the same concept. And going back to your original question, that will be a type of, that will be something that I would think of as a deep learning model, but that also counts as machine learning, because it's definitely just not that complicated yet.
It means, but that the thresholds and the weights, they change by themselves?
Yes. They're initialized, they're typically initialized random. Like you will have random numbers there between 0 and 1, or -1 and 1, for example. And then you do this thing called backpropagation, and don't ask me how it works, because I wouldn't know properly. You know, it's one of the things where you know how it works, but you don't really know because you can't explain it, right? But yeah, you basically you have a function that will you test your input and your output. You see if the output is correct. If it's not correct, you're gonna back propagate. So you're gonna send a signal backwards in the network to change the weights a little bit in the direction that will minimize the error, will minimize the chances of you making that mistake
but
again.
For example, if you try to learn to teach chess, there's not a wrong move. Like
the target there will be you won or you lost. And you will not use this type of model, but in general, yeah.
Okay. Because it's not like one action and one. Yeah. Okay.
Yeah, exactly. Then you would use deep, how do you call it? Reinforcement learning. And Andre, you already interviewed him, so I hope you asked him stuff about that. But Andre is an expert about that. He did his thesis on it.
Nice, that's perfect. But I have another question. Is this network with the neurons, is it always like layer and they're all only propagating in one direction and next and next and next, or can it be like a random like a brain where everyone's impacting each other?
I will not say it's always like that, because I'm sure someone did it differently, but it's almost always like that, where you have one input and one output and it always propagates forward.
Okay.
And I hate that. And I think that's why we don't have AGI yet. Okay, like that's a big jump forward in the conversation, but like I feel like I've argued about this with some professor, like where I was saying the brain doesn't work like that.
It's not always professor forward.
Exactly.
It's
right?
Like
you have multiple, and also not every neuron, like you have skip connections where like layer 1 connects directly to layer 5, like a neuron from here connects to here without passing in between, and a neuron from here will connect back to the start to give forward and backward information. And the thing is that I think that ChatGPT, right? Why don't I think it's conscious? It's because it gets one input and outputs one output, like one syllable, one token actually. And then when you see the whole stream of output, it's not actually doing that as one output. It's doing one syllable at a time with the input of the initial conversation plus the syllable generated plus the non plus one. And it doesn't have a continuous activation. It's not able to think on its own when it's not talking to someone, because it doesn't loop back the output to the input. You just input a lot of times and get a lot of outputs.
I give you this input, this output, this input, this output again. And it's like input, output, stop, and then start again.
Exactly.
Input, output, stop.
Exactly. And so if you pause it stops thinking.
Yeah.
Right. That would... And also it has zero independence in what it wants to think about.
Okay, so
I think it would be interesting to loop it back to itself. They do it in some way when people put two versions of ChatGPT talking to itself, right? But I would like to see it on a deeper, like neural level, like you connect the neurons in it with themselves and just let it run. And when it feels like it will output something. And I don't even know what feels like it means, because it's not a well-defined concept, right?
If you say the neurons are touching, like going back and forth, then it means that they're like circles going around, even when you're not texting with it. It's
exactly.
Like there's like an event going here. Some things are changing. You can maybe even make it like the brain, that the connections that I used more get stronger or something. I don't know.
There's a lot of things you could do with that, right? But what I would like to see, and I don't know if it has been done already. I think I should really find out and maybe, come back for a follow-up when I do find out, because I think it's really interesting though.
I'm pretty sure that people did. I think when I was trying to learn a little bit about neural networks, I saw that there were like somewhere that it looks like random, but I don't know if it's like in a larger scale. Maybe it was just like too, I don't know.
There are models that are more similar to how the brain works. And in that instead, for example, Giulio knows really a lot about them. It's called spiking neural networks, where it is somewhat continuous. Well, of course, it's digital, so it can't truly be continuous, but it's a good approximation of a continuous brain. And But the problem with those is that they really don't work so well yet. Like people have been researching about them for a while, and they don't have great results as far as I know.
Yeah, and these normal ones with the layers, they built ChatGPT, so they're like,
yeah, they work so well,
good.
right? Like,
it's like
that's the problem.
It's crazy how.
And I feel also like looping ChatGPT's neurons back on themselves will just make it way less efficient somehow. But I feel like it will be more true to how the brain works, and it will also. Like if you give it the chance to think when it's not speaking, and think again, it's not a proper word because unless you believe it's conscious, it's not thinking, it's just crunching numbers. But then again, what's the difference, right? But at least I would like to see this thing tried to know if it's gonna just always end up, looping and repeating the same thing, or maybe get stuck where like all the signals go to 1 or 0, and you just have a string of neurons that's active and nothing else ever activates because it found a stable solution basically to the equation that it's approximating. That would be language for ChatGPT. Yeah, I don't know. I think about that sometimes and I'm like, why does it not work like that? And also, as I said, I was talking about this topic with a professor and explained pretty much the same train of thought. And the professor was like, yeah, but the brain doesn't work in a continuous way. And I'm like, wait a second.
Tell me about that one.
Well, it kind of does, but he explained to me that it's so close to being cyclical, where there's like something starts, a neuron starts firing in a part of the brain, and then there's a cascade effect in the whole brain that will synchronize basically, to where it's almost as if there was one input and one output, the input being this first activation and the output being the cascade effect of neurons activating. And it doesn't usually go backwards. But I don't know, it feels like there's something missing there.
Wait, when one neuron fires...
Not necessarily one, but like a group of neurons, right? You see something that stimulates
so
you.
is it, does he mean like the brain waves? Because I think that's maybe true that like... Yeah. Is it like with the brain waves?
It is about the brain waves. Yeah.
Okay,
yeah.
So because...
But they're like very well synchronized, and
that means that all neurons fire, all neurons break, all neurons fire, or like most of them fire, most of them break. And
that's a better explanation than what I said, but that's what I'm referring to.
But still, I think they're back propagating, or however you call it, or like
they're exactly
sure,
right.
like,
they're synchronized. So he used that to argue with me, like, no, what you're saying doesn't make sense because the brain doesn't actually have multiple directions of communication because they all start at the same time and end at the same time. But like, come on, man. Like, I think you're right. Like, they're very well synchronized, and there's maybe 99.99% of the neurons are firing at the same time. But you know what that means? There's still like 100 million neurons firing at a different time. And they do something. I don't think they're just, firing for no reason. They still have a role in how you experience the world.
And even if they fire break, it doesn't mean that that it's not continuous, because they are, if they're all connected to each other, and then you don't have like it's never really off. It's like maybe it's like,
that's what I'm getting at, right? It's never really off.
It's like there's no there's no moment where it really stops. It just maybe they're just like recovering, but they're not like
not processing anything anymore.
Yeah.
So I really want to. Well, I guess spiking neural networks are an approximation of that, where you actually have this more continuous way of operating.
Mm-hmm. Damn, that is super interesting. Like like another thing is the difference between brain and like neural networks is that in the brain you also have like all the chemicals.
Yeah.
And that's like, it's not only the signal. It's like
Man, I have an
lots
idea
of-
about that as well. But
you
again,
could- tell me.
yeah, like you know how I'll do a small I'll go on a small tangent. Hopefully, it's gonna be small. You know how in the Zettelkasten, and so like the how to take smart notes book, the author is like, you can't start writing about a topic if you haven't first read what other people have done. So that's why you have to take research. Like when you do research, rather, you're reading a bunch of stuff and you don't know what you're going to write about because you don't know what's already been done. So you should first learn a lot about that topic and then like, oh, there's a gap here. Let me fill that gap. So sometimes when I talk about these things, I feel like I should learn first what's been done thoroughly, and then I can think about closing those gaps. I know other people who are just like, let's do things, let's start doing things. And in that sense, I feel like I might have some bit of imposter syndrome. But on the other sense, I also feel like, these are big and complicated topics. Of course, I must be missing some of the research that has been done in there.
So you mean that you are afraid to like say, oh, I have this idea,
Exactly.
and in the end there's like
And I feel
somebody else that already had this idea, and you're like, okay, it's not my idea really, I should have just read a little more.
Exactly. So with that let's say forewarning, my idea is to, because as you mentioned, in the brain we also have all the chemicals and stuff like that, but what the chemicals do for the most part is modulating the activation levels of different parts of the brain. So like, for example, like the most talked about chemical in the brain is probably dopamine. That is gonna, when you have more dopamine or less dopamine in your brain, it's gonna change which parts of the brain get activated, which ones are more active or less active. Or for example, it's gonna reinforce some patterns by making them become more activated when you do something that releases dopamine. In that sense, neural networks don't have something like this. So what I've been thinking about is to make two neural networks. Like it's like you have one that is flat, right? A neural network that I was describing earlier, like a multi-layer perceptron, like a basic neural network. It's gonna have inputs and outputs and a lot of neurons in between. What if you make another neural network that's kind of like two slices of a sandwich, right? One is going to be the main one, which is going to be the neurons in our brain. And the other one is going to be a network that simulates emotions, as in the chemicals that are going around in your brain. Mm-hmm. And all it does, it doesn't have an output, but it does have an influence on changing the weights and the biases of the other network. So
the input would be the underlying network, and the output would be also on the underlying network.
Yeah, kind of something like that, right?
Yeah.
And I really have, like, on a conceptual level, I think there's a path there, but in practice, I don't know how I will implement it. But
I think this could be.
Does it sound interesting? At least that's
of course.
You know,
if you use this, I think this could like actually simulate, because this way you can like pretty much simulate also like all the different kind of neurotransmitters.
Yeah.
Like you don't really simulate them, but
no, you just approximate them.
Yeah.
It's just a number, right? You reduce it to a number, but the function will be the same.
But you can make like, okay, because in the brain it's the same. Like if like this area of my brain is active, then there's a lot of dopamine like released in my brain, and because of this dopamine, like another area gets more active, and you could build the same, like the underlying network. You use it to, like, when those patterns of neurons are active, then then it reaches like the threshold for input in the upper layer, and then in the upper layer something happens, and then it has like an output on another part, and like this multiple times.
Yeah.
Or I don't know.
I don't really know how one will go about implementing that, but I feel like there's a path there. I feel like that would be a PhD level type of research, though. It will not be something I'm able to pull off. But I'm gonna, talk about it with some professors in the next days and see if it could be a thesis.
That's really interesting. Especially you could stack and stack and stack. Like you can stack a lot on top of each other, and look what happens. Like, you don't have to approximate
Yeah.
anything. You can just stack them on top of each other. It's like, it's maybe even similar to, then in this way, it maybe still be, but you could use like this upper layer to back propagate, like to start inputs on one part and get them
Mhm.
like back, like then it's not super linear anymore, maybe.
The problem with something like this is, how the heck do you train it? How do you
Yeah.
train emotions? How do you define emotions, first of all? Like,
No.
like
First thing, you don't even, like, of course you can train emotion, but I think this would be something, or I don't know if, of course, if you can, I have no idea. But the thing is, just try this kind of neural network if it has like new or better abilities than the ones before, and just see what happens. Or
it's not as simple as that.
yeah.
Because like if you build it, you have to do something with it, right? Like what does it, if you have to have it separate from the main thing and not just be this main thing but bigger, it's gonna have to require some different way of handling it as well, because otherwise it's just a big neural network. I don't mean a big neural network, I mean a neural network with an extra dimension, basically. And that dimension just doesn't contribute into the production of the output, but it contributes in altering the network itself over time. So what happens is, I could give you the same input multiple times, and the output, and maybe the network gets bored, and it's gonna start giving you a different output after a while.
Mhm.
Because, for example, this additional layer could be the continuous part that we've been saying. Instead of having the main network, you leave it discrete as it is right now, for example, for ChatGPT, and then you build a version that has an additional layer, and that additional layer is continuous, and it emulates emotions. So you get something the first time, and it's going to be like, oh, interesting. Let me, respond by activating these neurons. And then you give it again and again and again, it gets bored. Or you give it, this is where it gets tricky. You give it something that it likes. What does like mean? I don't know. It's going to answer in one way or another way. What I'm trying to do in this case, in this thought experiment, let's call it thought experiment, it's not to create a very efficient and useful network. It's just to simulate chemicals in the brain to make it feel more sentient, I guess. But there's so many variables and like unknowns about something like this, where I don't know how I will even tackle the problem. Probably with some research, though.
Yeah. It is interesting for sure. One question before we end this. Do you think that this, if you do this, if you try to simulate the brain, do you think by simulating the brain you can build something conscious, or like AGI, by like simulating how the brain works, or is this something totally different?
In short, yes, you can. I believe you can get to. Well, you asked me actually two things. Do I believe you can get something that is conscious? Yes. Do I believe you can get something that is an AGI? Yes, but they are not the same thing to me. Where you can have an artificial general intelligence that is not conscious, to the point where I believe ChatGPT, like GPT-5 or 6, if it's the same as it is now but better, it is an artificial general intelligence, because it's, well, obviously artificial, and it is intelligent. Like, it outperforms humans on a lot of tasks, and eventually, probably, if you keep improving it, it's going to outperform humans on most, if not all, tasks. So that is going to be artificial and general, because it works on all tasks, and intelligent, because it's better than human on all these tasks. Will they say that ChatGPT improved will be conscious? Probably not, because of the thing we were talking about earlier, because it takes input and output and then it poses. it's like literally an equation, just an extremely complicated one. And it does not have any agency over its own inputs and outputs. It cannot affect what it's going to get as an input. Maybe it can, like in some indirect way, but the neurons don't talk to themselves. There's no internal communication. There's only a forward pass. That's why I think it could be artificial general intelligence. It will not be conscious. On the other hand, I believe if you do simulate a more complex version of that, where it actually has a higher degree of agency, and it can talk when it feels like, it can output when it wants to, and not output when it doesn't want to, regardless of what it's taking as an input. Because it could have no input and still produce an output if it feels like it, and it could have an input and it doesn't answer you because it doesn't want to right now. It will be less useful probably, but it will be something that feels way more conscious to me. And, I believe being conscious does require being an artificial general intelligence in a more loose term of the way, where it could in principle talk about everything. It doesn't have to be better than humans at everything to be AGI. But if you're better than humans at everything, I will definitely say you're AGI, but just not conscious.
Okay, man. This is interesting. I have to think about this.
We can talk about it in saunas next time we go together.
Oh, yes. And okay, man. Thank you, Guido. We'll do this again.
For sure.
Yeah.
When I've decided a topic on my thesis and possibly also executed on it.
Sorry, I didn't help you this time.
It's fine.
Maybe we can. Yeah, it's okay. See you, man.
It's been a pleasure. See you next time.
This has been a Rational Optimization podcast. I hope you learned something. As you may know, I'm trying to make this podcast as good as possible. Like, I'm trying to provide as much value as I possibly can in every episode to you. So today, I'm not asking you for like a 5-star review or anything like this. I'm asking you, could you please, if you have any idea what I can improve to make this podcast, or to make each episode, or to just make this episode, if I would do it again, more valuable to you, can you give me feedback? Like on Spotify, there are those feedback boxes, and on YouTube, you can write a comment. It would be really amazing if you would help me to make this podcast as good as possible. See you in the next one.